Alright, so today we're going to talk about the sampling distributions of p hat. In your notes it has that p with the little caret thing on top. That is p hat. I unfortunately could not figure out a way to type that into the computer, so that's what you get. You get fat. Let's see. Learning targets. Today you're going to tell yourself, well, I can find the mean and standard deviation of the sampling distribution of p hat. 2, I can determine if a sampling distribution of p hat is approximately normal. And 3, I can use a normal distribution to calculate the probabilities of using p hat. So what does p hat represent? Well, that is your sample proportion. So an example of this is, 210 out of 501 American teens do not know all 50 states of the United States. So the p hat in this case is 210 divided by 501, and that equals 0.42. And so we do this a bunch of different times. We gather 501 random groups of American teenagers, and we get the number of them who actually know the United States, all 50, or do not know all 50 United States, and then compile them into one giant sort of dot plot chart of results that eventually turns into a normal distribution. So, what can we say about the shape, center, and spread of p hat? Well, fortunately, when we gather enough data, it will eventually turn into our normal curve. The shape of it is approximately normal. The center of p hat is going to be equal to the mean of the population, so that makes it a unbiased estimator. And the spread, as per usual, as the sample size gets bigger, the spread gets smaller. Boom. So essentially, we can do everything we've been doing with normal distributions with sampling distributions of proportions. So on to the next slide. So what is the mean of a sample proportion? Well, we know because the sample mean of a sample proportion is an unbiased estimator, that means it is the same as the true proportion of a population. So that means, let's say, out of 1,000 teenagers, we found that 700 of them have binge drinked before. And we did that multiple times. Eventually, we'll say like, oh, the mean of our sampling distribution is around 70%. That means we can say that 70% of all high school teenagers have binge drinked. And it works the other way around too. Like if I said, um, you know, 20% of all students have participated in sexual activity, and I gathered a random sample of 500 teenagers, probably around 100 of them would have had sex. If I did this multiple times, yes, there'll be some groups that have a little bit more than 200 teenagers that have had sex, and some groups will have a little less than 200 different people having sex. But overall, the average of all the different groups of random high school teenagers I found, the average would be around 200. What is the standard deviation of a sample proportion? Well, luckily, sigma, we have this cute little formula. Sigma of p hat is equal to the proportion times 1, the square root of the proportion of times 1 minus proportion divided by the sample size. So the square root of p times 1 minus p over n, where p is your sample proportion and your sample size is n. And so in order to make sure that we can actually use our proportions, our sampling distributions correctly for the purposes of the next couple of problems, we need to check for two conditions. The first condition is the 10% condition, and that's to ensure that our sample size is less than 10% of the size of the population. And so we can make sure our sample size is a small fraction of the population. What is large counts condition and why is it required? And that's going to be your sample size times the proportion has to be greater than 10, and your sample size times 1 minus the proportion is also greater than 10. I said less than 10 earlier, but I meant to say greater than 10. Greater than or equal to 10. And this is to ensure that we have enough successes and enough failures for the conditions to be satisfied. If it was like less than 10%, I mean, there's even an opportunity of like not having a group that does not meet the proportion requirements. So we want to make sure that we have enough failures and successes to make our standard sampling distribution. With that, if you need to pause the video, go back to a few slides, check them. It'll be fun because right now we're getting into a couple of examples. Dun dun dun. So, about 75% of young adult internet users watch online videos. Suppose that a sample survey contacts a simple random sample or an SRS of 1,000 young adult internet users and calculates a proportion of p hat in this sample who watch online videos. What is the mean of the sample proportion? Well, because the sample population proportion is 0.75, the sample proportion is also going to be 0.75. What crazy. How easy is that? Mind-blowing. Find the standard deviation of the sampling distribution of p hat. Check that the 10% condition is met. So 10% condition. Well, obviously there are millions of high school teenagers in the United States, and I'm like 99.99999. I'm 100% sure that 1,000 teenagers is much less than 10% of the population of high school teenagers. If you want to argue with me about that, feel free to send me a text message, but I'm like 100% certain. And so with that, now we need to check the standard deviation of the sampling distribution. And so remember, we can use our formula, p times 1 minus p over n and all square rooted. Just plug in some numbers. Our proportion is 0.75. 1 minus 0.75 is 0.25. And we're going to divide that all by 1,000. So our standard deviation is 0.01369. Is the sampling distribution of p approximately normal? Well, we can check the large counts. N times p equals 0.75 times 1,000, and that equals 750. N times 1 minus p is the same thing as 0.25 times 1,000, and that equals 250. So yes, this satisfies the large counts condition. If the sample size were 9,000 rather than 1,000, how would this change the sampling distribution of p hat? Well, like we said earlier in the video, as our sample size gets bigger, our spread gets smaller because we're getting more information, we are getting more accurate data. And so in that case, there would be less variance. Crazy, 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 crazy. I like that. That's so much fun. Yes. So example 2, a polling organization asks an SRS of 1,500 first-year college students how far away their home is. Suppose that 35% of all first-year students attend college within 50 miles of home. Find the probability that the random sample of 1,500 students will have a proportion within 2% of p hat, equaling 0.35. So what the question is asking is, well, what's the probability of us taking a random sample of 1,500 students and the proportion of each of those samples fall between, well, 2% of 0.35. So what's the probability of us taking a random sample and finding 37% to 33% of them living within this proportion. So we're looking at the probability between 0.737 and 0.33. So before we get to anything at all, we have to check all the conditions. We need to make sure that we can actually that this distribution is actually a normal distribution. That's where we check our 10% condition and our large counts. Obviously, again, there are millions of first-year college students, and 1,500 is going to be less than 10%. If you want to argue with me about that, send me a text because you're wrong if you think I'm wrong. Large counts, 0.35 times 1,500 equals 525, and 0.65 times 1,500 equals 975. Boom, bing, bang. How cool is that? So all the conditions are met. So now we need to calculate the mean and standard deviation. Well, the mean is just going to be 0.35. And our standard deviation, it's going to be 0.35 because the proportion of the population is 35%. So the same thing will be for the sample. The standard deviation is going to be the square root of 0.35 times 0.65, all divided by 1,500, and that is going to equal to 0.0123. So now that we have all this information, we can go into our calculator and then find the probability that a random sample is going to have a proportion between 0.33 to 0.37. So I'm just going to plug this all into our calculator. Remember, you would use normal CDF. Lower bound is going to be 0.33. Upper bound is going to be 0.37. The mean is 0.35. And the standard deviation is 0.0123. You hit enter. And you get this nice little chart right here. To get credit on the AP Stat exam, you would need to at least draw this curve right here with the shaded 0.35 in the middle with 0.37 to the right and 0.33 to the left. You would need to draw this picture to at least get credit for this. And with this, our answer is 0.89. So this accounts for 90% of all proportions of a sample size of 1,500. So our answer is about 90% of all random samples of size 1,500 will give a result within 2% of the true proportion of the population. Whew! That was fun. Yes. Alright, I'll see you later. Deuces, y'all.